Hello and welcome to Section 8, Part 11 in Suits' Fabulous World of Art. I'm joking. This is going to be the next part in calculating our navigation, where we're going to figure out where our entities are going and assign our entity positions and update the entity position data. What we've done in the previous parts is we've determined the group positions, we've determined how much space they take up, and we've organized them. So these groups down here, they know exactly which spot they're going to, wherever they're coming from. So now we actually want to calculate which entity is going where in this group position. So this will be like so, and I've deliberately made this one bigger just to represent that the size is taken into account here. So this is the positions. So we've got position 1 and 2, 1 and 2. Now we need to know which way this is going to be, so which entity is going to which spot. So we're going to do the same as what we did for the group passes. We're just going to say, well, there's two entities in here where it's divided up evenly into two temporary positions and assign an entity to a position. Then once we know which entity is going where, we can then calculate the exact positions and spacing and what we want. So that makes absolutely, you're probably thinking, well, what's the point when it's just going to be that anyway? But this is why I included this, because this is where it makes more sense. So this group here is just going to go, we just want 4 even positions spread across the space that's been allocated to this. And then we don't really care if these two are moved over more and there's a bigger one here. So this is, if it turns out that all these are these positions, this is the movement, we then assign those to those positions, and then we can recalculate the formation because we know which entity is going to be here now, and it's going to be the big one. So it's going to be something more like this. Where's the line? Yeah. So that's going to be more like that, and then these, I don't think I made that circle big enough to really show it, but it might be something more like this, and it just adjusts to the line. And the more the different sizes you have, or the different spacing requirements, like maybe this is the same size but you want it to have more spacing, that'll factor into this. All right, so let's do the first part. Let's create these positions that we need so we can then assign the entities to the positions. So coming back to our formation data, we're going to need another function in here. We just need the navigation data and the formation data. And then for each of the group positions, we're going to create the entity positions. So we're going to loop over our positions. And then we're going to do similar to what we did with the groups, right? So we're going to create the entity positions. We're going to then assign them to entities, doing that bulk calculation, so who's the closest and who should move where. And then we're going to update the entity position data. We're going to break these into into functions. I'm just going to fill these out for the moment, and then we'll create these functions as we go. And then passing into here, we'll need to pass the navigation data into each one. And then also want to pass the index of this position, so we know which position we're working on, and the formation data for this one. And then this is going to be the same as what we pass into the update. And then for the assigned positions, we just need to pass in the position that we're working on. All right, so let's create this first one. And we want the navigation data. And while we're here, we're going to create the other two. Whereas this one's just going to be the same. And then this one's going to take the struct of the position. So formation position, like so. build all those out. So we want to copy that check again. I didn't actually use selections in that, realized. We don't need to pass selections into that function. Anyway, fix that in a sec. And one other check we might do here is if the navigation position is not valid. So we can copy, we're going to need the same setup, this left-right spacing again. Because we're kind of building the formation again, it will just be, it's exactly the same process, but it's not groups, it's entities within a single group. And we're going to want the odd count again, same as before. We'll just copy it from up here, up further. But instead of selections, it's going to be the navigation positions index. Oops. And then it's not the position, so it's going to be the selection entities. So for how many entities we have, whether it's odd count or not, is what we're doing there. So now, like the temporary group positions, we want to just get an average spacing that we're going to take up. And if you recall, we actually assigned that up here somewhere. So when we're assigning the position, we are updating the spacing in the position so that the position knows how much the selection that's been assigned to it should take up. So we can grab this. And then we can create, we just want to create an average spacing here. So we don't want to factor in the size of the units or anything like that because we don't know who's going where. I'll change that to index in a sec, but we'll do some checks over this, but we're going to divide it by the number of entities, so which is this one, which will give us an average spacing of each position. So to protect against the divide by 0, we'll move this out. And we'll just put in a default value here, 250, so should be overriding this anyway. And just to stop using this massive long thing here, I might just put this at the start. I'm going to make a int, sorry. That's the number of entities, and we can just swap this out. Make it a bit more readable. Then here we can check if the entity count is greater than 0. And the selection spacing here is greater than 0 also. Oh, bounced out. There we go. So that's got us our data that we need. And we can go into creating each of those positions based on where they need to be. So we want to create a position for each entity. So we're going through the entity count. And then this is going to start looking real familiar again. We might even cheekily copy some from the original group setup here. So we'll need this and this. So we're going to be adding positions to the navigation position. So this is the group position. You come into the data. This is the entire, this is all the positions. And then in the formation position, you've got entity positions, which is similar again, but it's for entities, individual entities. And this is what we're going to be populating here. So coming back, let's grab our So this is by reference, that's why we can update it. And we should be able to access the entity positions and just do an add. And then in here, we need to pass 3 things. So we're going to need the destination of this position. So this, because this is the, again, we're doing a odd count. So if we come back here, which this one has an odd count. So we're doing this position, which is the group position. And we can get that from the navigation position that we're current. So whatever we're basically grabbing this position. So we're doing this group and we're grabbing this position from the navigation data and assigning that to the first entity, which is destination. Then the next one, so this will be rotation. Oh, sorry, I'm not. So this this entity position is a struct entity position. So I missed the step here. So this will be creating a new struct. That might make more sense. And then we can, so it's this constructor here. There we go. Coming back. This will be the destination again. So it's the formation position, which is just happens to be the same as the entity position in this case. And then the side will be the center side. So it's center side. All right, and then just like before, after this position is assigned, we then want to add our spacing left and right, which will be our average spacing for this. And just duplicate that. Add that to right. So that's so we've assigned that position, and now we want to assign the spacing from here to the next position, and that's what we're doing. Adding spacing to the next position here, spacing to the next position here. And if that is the first iteration, we just want to continue then, and then that'll come into where we can start doing the left and right. So same as before, we're just going to use the modular to check if it's left or right. Now, if it isn't an odd count, we need to factor in the spacing for a non-odd count. So in the case of this one here, let's move this out a sec. In the case of this one here, we know the group position, and we want to add half the spacing to here and half the spacing to here to get those left and right positions. So we're doing left first, so we need to add half spacing left, which will give us this position. And then we can assign the position and then add a full spacing to the next position. It's just that first one that needs that half spacing. So we can check that by if spacing left still has a value of 0, we know it's the first one. And like last time, we're going to just double check it's not an odd count. And we're going to add the, what do we call it? Average spacing, sorry. And then we're going to add half that spacing. So now that we've got that half spacing, that gives us the next position, or the first position. So we can now add the position. I'm not going to go through and explain all this. Is exactly the same. Like if I come up anywhere here, it's just all the same as this. I might just copy all this. Copy and the only difference is, instead of assigning it here, it'll be index, entity positions, and then we're going to add, so adding a position here. It's going to be the same as this. It's going to be left side. And the destination will be, the the position will be the destination plus our local offset. This one will still be destination because it's the formation position. Rotation's still right, so that's all good. And then after that, we need to add the spacing to the next position. So when the next position for the left side comes in again, it'll go skip over this and assign the position, add the spacing. And we can copy all of this to the right side. Change all this. Spacing right. And we don't need the inversion for the right side. And this is right side. Now for the non-alternating formation, we want to check if it's the first position. Sorry, it's not the first position. If it isn't the first position, we're going to add spacing. And then we're going to add the position. This is going to be no side. And here, instead of just calculating this, we're going to do, so it'll be, if it is the first position, then we just want to use the destination. And then if it's not, so the first position will be the formation position, and then the rest of the positions will be offset. So that's our positions done. So now we have all these positions signed, like so. Something like that. Don't really know who's going where yet, but that's what we're going to do next. We come back to here. We've just done the create entity positions. Now we're going to assign the entity positions. Now we can go to where this is used before, and we can copy this whole thing because it's going to be similar but slightly different. So in the assign entity positions now, instead of being selections.num, it's going to be the number of entities. So we can swap this out here and down here. So that's our index array that we're going to shuffle to calculate all the distances to the positions. Still going to do check the distance on each position and use that to score it. And then instead of this being selections lead, we're going to use each individual entity. So it's going to be positions.j, and we don't need the lead because it's just the entity. And then it's not navigation positions we're checking, it's just the position. Entity positions is what we want to check is valid, because that's what we were populating in the previous thing. We were adding to this entity positions array, so there should be a valid entity position at this index that we're checking. We're getting the position of this entity position and then we are checking that the actual entity entity's position to that position, and that's getting added to our total distance scoring setup. All this is still the same. Going to pick the best one. Oh, we need to pass the number of entities into here also. And then this will be the entity. We probably need to change all of this. It's going to be similar to this. But this, we just need to check the entity's valid, so copy all this. Why do I do the wrong bracket? And then we want to update the entity position for the best array, for the current best setup, and we want to set the owner to the entity. And the source location, let's just copy these over. I don't think we need selection actually. Anyway, we could add a source location, and then that way if you do an undo, you can bring back entities exactly to where they were. But let's just skip that for now. This is what we need. We just need to assign the entity to that position so we know who is in that entity position. And that's our permutations done. So it's using that same method there. We don't need to redo that. Figuring out the best combination of who to what position, and then it's assigning those entities to the best positions. So now onto the update entity positions. We'll grab the check here, and we'll grab the spacing again. And then we're going to iterate over the positions again like we did last time. And this will be the navigation positions for this index. So now we're iterating over all those entity positions we just created and assigned an entity to. And we want to just make sure, so we're checking that the index is valid. Let's just make sure that this iteration is valid. It's not valid, we'll skip over it. And that is valid check is what we put in here. So we're just checking that this position has an owner. So now we're going to do similar thing again. We'll get our, we want the offset, reset the offset. So we'll copy this as well, copy all this. One other thing we have to do here now though is that because we know what entity is in this position, we want to get the actual entity spacing. Let's just do a command. And we're going to just put a default here, written anyway. And now we need to go to that entity, so we're going to go to the entity component. It's going to be this dot owner. That's the actual entity, long one. You could probably save that to a variable, drawing it up. But that's the only place we're going to use it, I'm pretty sure, so it doesn't matter. So now we've got the entity component, get. We have get spacing, minimum spacing, I think that's what we're after. And we need to assign that to our required spacing. Yep, so that's getting the minimum spacing from the data. Now that we have that, we can start doing the positions. So we need to check if this is the center. Let's just duplicate that a couple times. This will be left. So that's assigning the positions destination. So that's the group positions destination to this entity's position. And then we're doing the same again, we're adding that half spacing. But this time it's the actual entity's required spacing plus whatever the entity spacing is for the group, which I believe we have in our position here. So we got the group spacing, we called it. I believe that was, we look at where that is set. That's average group spacing. We might have to re-grab that one, or perhaps update this. Actually, we weren't doing that, were we? We're not updating this. Doesn't look like we are. I think what we might do is find where that is. Yeah, well, let's just do that first. We'll come back. So when we assign the group to a position, so assign selection positions, in here we probably want to assign spacing of that group. So it's the actual spacing of the group that's been assigned to it. Save us doing it later. So this will be the selection, get group spacing. There we go. So that's easy enough. We come back. And now in, where were we? Yep. So now we can add the required entity spacing. That's on. There we go. That's the center position sorted. And then if you recall last time, this will be the same as the group. So if this is left position, so we're going to add the half first. But, we're figuring out the next position. So say we're calculating this position. So we're going to add half of the required spacing of this entity, and then half of the group spacing, which gives us the start of the next position. And then we add another half of the group spacing, and then half of this entity's required spacing, which gives us the center position for the entity. So we can copy this. On our entity, we actually have a variable called spacing, and we're going to save that spacing in there. So let's grab this. So we're just saving that offset spacing from the previous position, and this will come in handy later. All right, and now we need to invert the local offset again. This is the left side. Let's just copy it. It's all the same. Let's copy all this. And we want to assign our position, which is the same as this. And it's going to be the same as this position, just with the local offset. And then we want to add the other half of this entity's spacing. So if we were doing this one, now we want to add its requirement plus half the group spacing, which gives us the start for the next entity if there is one. And then we're going to copy all that into the right side. And that is good. And then we're going to do our non-alternating again. Let's copy that from up here as well. And instead of doing just the spacing, it's going to be the same as this. It's going to be the half spacing, because it's just in a different manner. And then we're going to do the same. We're going to save to the spacing variable. We're going to save that spacing that we just have. If I rotate that, I think I forgot to do the rotation here. It's going to need that rotation there. I wonder if I forgot that on the groups. Hang on, I'm just going to come back up. Let's got it. Yeah, I did. Sorry about that. Yeah, it wouldn't have factored in the rotation at the destination there. Well, maybe we'll see what happens there. I don't know. We'll probably need to change that rotation to the rotation of the direction of movement or something like that, I think, for especially things like column, but let's keep it all the same. So where are we? Assign entity positions, update entity positions. And then we can assign the position. And again, we just want to set the first position to the formation position only, like so. In that this loop here, we're going through each position in the formation, each group position, and we're setting the entity positions in each group position. Now we need to call this what we were. So in assign formation positions, we need to add that. So this is where we would have finished updating the group positions, and now we want to create the entity positions. Like so. And now we need to calling this original function create formation. So we're going to call that back in our player controller command. After we've gathered all the data, created the command data, and then we send it to the server, and then we add it to the queue. What would normally happen in here is every time we add to the queue, we'd then call for a dequeue, like we're doing here. So we add a command to the queue, and then we dequeue, but what we want to do is we want to bypass dequeuing. So we don't want to execute this command until we've created navigation data. So when we issue the command to the server, what we want to do is we want to enqueue the command in our command queue, but we don't want to pull it out until the navigation is created. So what we need to do is add it to the queue, but not call the dequeue until we come back from generating our navigation, which we haven't set up yet, but we will. So we're just going to change this up a bit. So this will be in here. We want to check if the command has navigation. So we can say new command. Do we have a bool for that? I can't remember. It's in the data probably. Has navigation, so we can just go new command data as navigation. And if it does have navigation, we still want to enqueue it. Sorry, what we're going to do is we're just going to queue it no matter what. But in the enqueue, we're going to remove this dequeue. And then if it has navigation, we're going to do, we're just going to do a create command navigation. We'll make a function for that. And we'll pass the new command. However, if it doesn't have navigation, then we are just going to call dequeue straight up. And there's one other thing we want to do here, and that is we're on the command, I think it'll be on the data as well, we have this should queue. And the reason why you want that is you might have a command, say a group has a bunch of commands in the queue, and you all of a sudden want to abort those commands and give it a new command, then this is what this setting will do. So should queue means it should be added to the queue. If not, it's just going to try and dequeue that command, no matter if there is already commands waiting for that group or selection. So I think where we set has navigation, which I think is in a constructor here. Yeah, here. So we're just going to set that here. So we're going to set should queue. And on the client data, we've got the modifier key. I believe the modifier key is an int. I know we've got the full thing still because we're on the client here. So now you can set this to whatever your queue key will be. I can't even remember what I was going to make that, to be honest. Let's call it control to add to the queue. So if I'm holding control and I click, then this is going to be a queued command. Otherwise, it's going to override. And then we want to check that here. So we want to assign that to the command here. So if we have a look in dequeue here, for the can execute, we're going to add an override if it's not, queue So that's going to basically override the can execute. It's going to execute it straight away. There may be some cleanup we'll need to do there later, but we'll just get that in there for now. So now we just need to create this, create command navigation. And it's going to take a command reference. So now we're up to the point where we can begin processing our command, and what we're going to do here is throw this to another thread, and then when it comes back, then we'll call the DQ command on the command queue. And if this command is the only command, that would make it execute, obviously. We're going to continue that in the next part. Thanks for watching. I'll see you there.